This is where we left off. We left off with 5x squared minus 125 equals 0. So we're solving by factoring. So we want to factor that. We want to change that into something that looks like a times b equals 0. That's the whole game here, guys. So what can we do here? It looks like a trinomial, but it's not a trinomial. It doesn't have 3 terms. There's a square here. You know what we should always do first? We're always supposed to common factor first. So we're going to common factor out of 5. Let's do 5 squared minus 25. Oh my Lord, look at what happened. We got a difference of squares now. That's a beautiful thing. That's going to become x minus 5 and x plus 5. And now when we set this equal to 0, now there's a couple ways you can think about this. Is there any value of x that's going to make 5 0? And the answer is no. There's no value of x that's going to change 5 to 0. So that's not even in the game. We're not going to play with that anymore. But is there a value of x that could make x minus 5 equals 0? And the answer is yes. The value is 5. And is there a value of x that could make 5x plus or x plus 5 equals 0? And the answer to that is yes. It's negative 5. And therefore, we would say that our answers are, those are the zeros. Those are the roots. Those are the solutions. Now, if someone asked you for the intercepts, you would say it's 5, 0 and negative 5, 0. Now remember, intercepts are points. These are the x-intercepts. These are the zeros, the roots, the solutions. All right, so there's a difference, but they definitely are related. Look it over at D. Now D is an interesting question. It's 7x squared equals negative 14x. Now, I can't do anything with this until it is equal, must equal 0. This whole thing is about the 0 principle. So if it's not equaling 0, we've got to change it. So it's got to become 7x squared plus 14x equals 0. You must make it equal to 0. Must equal 0. Otherwise, there's no point in doing this. Now we're going to try to factor, because what we want are 2 things that multiply to give 0. Because if we find them, then either the first one's 0 or the second one's 0. So it looks like a trinomial, but it's not. It doesn't have 3 terms. It's definitely not going to be a difference of squares, because that's a plus. There's no such thing as a sum of squares factoring. Maybe common factoring can help me. I can take a 7 out. I can take an x out. Hey, it does help. I've got 2 things multiplying to give 0 here. Either 7x equals 0 or x plus 2 equals 0. Is there any value of x that'll make 7x equal 0? Yep, there is. 0. If I put in 0 for x, I'm going to get 7 times 0 is 0. The other thing to do is to divide both sides by 7, and you get x equals 0, and that's fine too. Or x equals negative 2. So those are your solutions, your roots, your zeros. Here's another example. Do you want me to wait a minute? Give you a second to catch your breath?
Just like 15 seconds, please.
Yeah. No problem. Yep. Not a problem. Okay, so now we've got another one. Now this looks like a trinomial. That's a subtraction sign right in there. But it's got to be equal to 0, so I got to move things around. So I'm going to do 2x squared minus 14x plus 24 equals 0. You need this to equal 0. Now it's just a matter of factoring. What type of factoring do we do first? Common, always. So it's 2x squared minus 7x plus 12 equals 0. Now I've got a trinomial. Two numbers that multiply to give 12, add to give 7. X minus 3, x minus 4 equals 0. What values of x will make this whole thing go to 0? Well, no value of x is going to make 2 go to 0, right? Because 2 is 2. However, if x equals 3, then this one will be 0. And if x equals 4, then that one will be 0. And if either one of them is 0, the whole thing is 0. So these are your solutions. These are your roots. These are your zeros. So 3 words mean the same thing. Zeros, roots, solutions. The next one, I had a bit of a hard time with the computer program I was using. So let me write it out a different way. So maybe it looks a little bit more like I want it to look. That should be a 3. There we go. So it's 2x squared plus 5 over 2 equals x over 3. Well, we're going to do something called clearing the fractions. And I think I've done this with you already, but we'll do it again. We're going to multiply each and every term by the lowest common denominator. So we're going to multiply each term by the lowest common denominator. So it's going to look like this. It's going to be 2x times 2x squared plus 2x times 5 over 2 equals 2x times 3 over x. And it's the 2x that is the lowest common denominator. I took this 2, I took this x, and I multiplied each and every term by it. Now, why did I do that? Well, I did that because look what's going to happen. Those denominators are going to divide out. They're going to be gone. And it's going to leave me with a much easier question. There is a typo in this question, though. I have made a mistake in the typo. Can you please take out that squared here? That shouldn't be squared. That should just be a 2x. So if you could take that out, that would be great. And that's going to leave us with 4x squared plus 5x equals 6, which is a much easier question to do. We'll do 4x squared plus 5x minus 6 equals 0, because we still need it to equal 0. Now we need to factor that. So I grab a scrap piece of paper because I don't want to do my factoring in my work. And it's going to be 2 numbers that multiply to give 4 times negative 6, which is negative 24. They're going to add to give 5. I'm thinking 8 and 3 already. And it's got to be negative 24. So a negative 3 times 8 is negative 24. And an 8 plus negative 3 is 5. So we found the numbers. So it's going to be 4x, all over top of 4, with an 8 and a negative 3. This 4 is going to come out of here. Now, I see kids do this sometimes. They'll cross this 4 out with that 4. That's wrong. You need to common factor the 4 out. So it's x plus 2, 4x minus 3 over 4, which means that this lovely thing is going to factor to x plus 2, 4x minus 3 equals 0. And again, I don't want to see this work. That's on scrap piece of paper. We get rid of it. So then we look for the values of x that'll make this 0. And one of them is x equals negative 2. And the other one is x equals 3 over 4. And I did that in my head, but it's pretty easy. Take the 2 over to the other side and it becomes negative 2. Take the 3 over to the other side, it becomes positive 3. And divide by 4. And I'll let you copy that down for a moment. I'm going to check to make sure that I'm recording this. Just a second. Yay! So whenever you have a fraction, whenever you're given a fraction, you want to clear the fractions. And it's going to make your life so much easier. Because what we get is a question without any fractions in it. Okay? I'll give you a little bit of time to copy this down before I start. So Sarah throws a ball along an arc that's given by h of d. So the function is h, and it probably stands for height. And d is the variable that they're using. And in this case, it stands for horizontal distance. So they're not using x's and they're not using y's, they're using h and d. The function is called h, and the variable we're using is d. Careful not to miss that negative. That's going to be important. And we've got d plus 2 and d minus 8. So, 3a. How far from Sarah does the ball hit the ground? The equation is negative 0.25 d plus 2 d minus 8. They want to know what's the horizontal distance when the ball hits the ground. So when the ball hits the ground, the distance is going to be 0. The height. So the height is 0 when the ball hits the ground. So what that means is we're going to have 0 equals negative 0.25 d plus 2 d minus 8. Well, that's different than what we're used to seeing. We're used to seeing it written like this. Which is no difference. There's no problem here. And so we now need to determine the values of d that will satisfy that. That'll make it equal to 0. Well, there's absolutely no values of d that'll make 0.25 equal to 0. 0.25 is 0.25. However, if d equals negative 2, then this equals 0. Or if d equals 8, this equals 0. So the question has been answered. how far from Sarah does the ball hit the ground? Now I have two answers here, -2 and 8. That's because this is a parabola that's going to look something like this. We have Sarah standing on the ground, throwing a ball. And that's the arch. And we found out from Sarah being 0, the ball is going to hit the ground at 8 meters away from Sarah. But we also found out mathematically that the parabola has another 0 behind Sarah. Now, the ball doesn't actually go that way. The ball actually goes like this. But the math doesn't know that. You're solving for the entire parabola. So the part that's not highlighted is part of the math, but it's not part of what's happening in the problem. So we omit this. We say omit. And we say the ball is going to hit the ground 8 meters from Sarah. The ball hits the ground 8 meters from Sarah.
Sir,
Yeah.
is the reason that we omit it that because it's a negative and you can't throw the ball negative?
Well, no, actually, because you could throw the ball negative. If we considered throwing to the right positive, then throwing to the left would be negative, would it not? The reason why, yeah. And so it's not the mere fact that it's negative. You need to be careful of that. It's not just the fact that it's negative. It's the fact that the negative doesn't make sense to the problem that we're doing. The ball didn't go behind her. It didn't fall behind her. She threw it in one direction and one direction only. She threw it this direction, right? And so the ball went like this. Now that's what the ball did. But the math for this parabola, the equation that we have for this, which is way up here, is bigger than the problem. Does that make sense?
Yeah, so you just have to, like, it's according to, okay, yeah, it makes sense. Yeah, it does.
It's according to the problem, isn't it?
Yeah.
You got to think it through. Yeah, but not just because it's negative. Be careful of that. Good. What height was the ball? Yeah.
Sorry, I'm kind of going off what Olivia said. So if you indicate that you, in your brain, think that left is positive and right is negative, as long as you indicate it, does it matter?
You still have to negate it because the ball never fell behind her, did it?
Yes, but if you say that she threw the ball to the left and then going to the right would be negative, it wouldn't matter?
Oh, like if you turned this whole thing around?
Yeah, like would anything change? Or would it just be directions?
It would just be directions. Yours would look like, now you'd be weird, and the rest of us would say, what are you doing, child? But you would have an answer that looked like this. Your ball would go up, and you would call this +8. And you would have -2 here. But you would be a kid that was going against the mathematical standard that we always do plus to the right and negative to the left on a number line. You would be flipping that around. And that'd be weird, wouldn't it?
Okay, yeah, it would be weird, but I was just wondering, like, based on perception, if like anything would really change.
No, so actually, you know what we would do mathematically? Honest? We would still set it up this way. We would still do this. We would still call that +8. As a mathematician, we would still call that -2, but we would say somewhere positive equals left.
Oh, okay. So as long as you indicate which way is positive and negative, it doesn't really matter.
Good girl.
All right.
Good
Thank
girl.
you.
Perfect. No, that's excellent. That was a great question. Have you taken physics yet?
Yes, that's why I'm asking.
Perfect. Yep, I figured. Okay, that was a good conversation. Okay, at what height is the ball initially thrown? Now you got to think about that a little bit differently. So if you're looking at the height that the ball is initially thrown, that means that the initial height d must equal 0. That means we're putting in 0 into the function. So it's negative 0.25 bracket 0 plus 2 and 0 minus 8, because that's where the d's were. And we're putting in 0 for that, for those values, because that's when the ball was initially thrown. So d equals 0 when thrown. Because think about it, the distance from Sarah from the ball is 0. As soon as she throws it, that distance starts adding up. But before she lets go of it, the distance the ball is from her is 0. So this is going to be negative 0.25 times 2 times negative 8. And I guess I'm going to have to use a calculator because I'm not very good at doing that in my head. So 0.25 times 2 equals times 8 equals, and I get 4. So what does that mean? That means that the ball was 4 meters above the ground when it was thrown. I can't spell. I'm really bad. Above the ground. And perhaps we should put thrown. What that means is that Sarah's height here must be 4 inches, so, or 4 meters. So if I draw this out, you got Sarah again. Here's good old Sarah. She's throwing her ball. Whee! Here goes the ball. It's landing 8 meters away from her. Whether that's to the right or left is up to you to decide. Okay, we had a great discussion about that. We could say that's to the left. We could say that's to the right, but we want to put positive 8 on this side, and we want to put negative 2 on this side. Otherwise, it's just going to look really weird, and people are going to think you're weird. And we learned that when the distance is 0, the height here, I'm looking for my green pen. There it is. The height here is 4 meters. So the ball was thrown 4 meters above the ground, which means it's going to go higher than 4 meters here, and then it's going to come down to 0. What is the maximum height the ball makes? Okay, so that's a good question. It wants to know what this height is, right? It wants to know, basically it wants to know the vertex. So this is what we know so far. Once again, I'll draw the diagram because I think drawing the diagram helps. We got the ground. We got Sarah. We know that Sarah is 4 meters off the ground. We know that this is at distance 0. We know that this will be distance 8. We know that this will be distance negative 2 from Sarah. And we know that we got a ball that goes something like that. So it starts at 4, and we have a vertex that's happening here that we want to find. Well, remember, the vertex is always halfway between the x-intercepts. So this is negative 2, and this is 8. So if I go 2 up to 0, I go 2 back to 6. So now I'm sitting at 0 and 6. If I go 3 and 3, so this is going to be 3. That's going to be a distance of 5 units. And that's going to be a distance of 5 units. So 3 is where the axis of symmetry is, because it's directly in between the two x-intercepts. That's the axis of symmetry. And it's at x equals 3. Or in this case, d equals 3. So we know that the vertex lies at d equals 3. So if we want to know the height when d equals 3, we're going to take the formula that they gave us for all d, and we're going to plug in 3 for d. Which is going to give us, so 3 plus 2 is 5, and 3 minus 8 is negative 5. So it's going to be 0.25 times 5 times negative 5 is going to be 6.25, which means my vertex is going to be 3, 6.25, but more importantly, this is my maximum height, is 6.25 meters. So now they want me to do a nice sketch, a pretty sketch, without perhaps little Sarah being drawn in there. So this will be distance from Sarah. So that'll be distance from Sarah along this horizontal axis. The vertical axis will be the height above the ground. I know that one of my points is 0, negative, or negative 2, 0 is one of the x-intercepts. I know the other intercept is 1, 2, 3, 4, 5, 6, 7, 8, 8, 0. I know that it crosses at 1, 2, 3, 4, because that was when it was launched. So that's 4, 0. And I know that it has its axis of symmetry on this line. So it's going to be a little bit above 6 at 6.5. So that's my vertex. My axis of symmetry, x equals 3. And we do our best to connect the points. Now that's the parabola. That is the parabola that comes from this equation. H of d, negative 0.25, d plus 2, d minus 8. That is the whole parabola. Not all of it makes sense to this problem. The ball only went up and then down. That's the only part that makes sense to the problem. It didn't fall behind Sarah, and it certainly didn't fall below the ground, or at least we have no reason to believe that it would fall below the ground. It didn't fall into a hole or anything like that. So the ball, notice the path of the ball is much less than the entire parabola. This is what I mean by saying that the problem is smaller than the math. The math has more information, but the path of the ball is only the highlighted part. Okay? It doesn't go below 0, and it doesn't go behind Sarah. I'll give you a second to think about that for a minute, because we need to talk about domain and the range of the path of the ball. It calls it the relevant part of the graph, or the relevant part of the function. We want the domain and range of just the path of the ball, not the entire parabola. So when I look at this, I need to get another color here. What's going to be a good color? No. Ah, that's a great color. Okay. So when I look at the domain, now remember we talked about domain a little bit. The domain of the ball means all the x values. Domain are all the x values. These are all the x values for the ball. They go from 0 and they stop at 8. And all the numbers in between, all the fractions, all the negatives are included. So it's all the numbers between 0 and 8, including 0 and 8. All the numbers between 0 and 8 and including 0 and 8, and all the real numbers. So every number in between except for the complex numbers. Now, when we look at the range of the ball, the range of the ball are all the y values. Well, the y values have a lowest y value of here, and they have a highest y value of way up here. So the range of the y values is going to go from 0 all the way up to 6.25. And all of the numbers are included, right? All the decimals, all the fractions, everything's included in here, all the irrational numbers. So we say y is an element of the real numbers. And that's how you do domain and range. So the range is the y values here, and the domain are the x values. But we're only talking about the domain of the ball and the range of the ball. I'm going to stop the video there and I'll take questions.